Picture this. You're at the 2026 Global Technology Launch.
Oh, yeah, the one at Changi Airport.
Right, exactly, under
Yeah.
that massive glass dome at Canopy Park.
Huh.
But the real showstopper is actually happening simultaneously on a stage over in Jakarta.
Right.
So the lights go down, the music swells, and out onto the catwalk rolls this strikingly angular, like cyberpunk-style motorcycle.
It's a crazy visual.
It really is. It just glides forward, perfectly positions itself in the dead center of the stage, and then with this smooth mechanical hum, it pops right up onto its center stand.
Which is wild.
Yeah, and here is the kicker. There is absolutely no human rider on board. I mean, you're literally watching a 400-pound machine balance itself and park like a ghost is at the controls.
It genuinely is a surreal visual.
Yeah.
I mean, we are so accustomed to the physics of two-wheeled vehicles requiring, a human element to constantly fight gravity.
Right.
So seeing a machine just simply refuse to fall over, it honestly feels like a violation of natural law.
It does. And to figure out how this machine is pulling off this reality-defying trick, we are unpacking a massive stack of international tech blogs, automotive reviews, and official engineering announcements today.
That's a ground to cover.
Definitely.
Yeah,
We are doing a deep dive into Omoway's Omo X, which is the world's first mass-produced self-balancing electric motorcycle.
Yeah.
And, whether you are a seasoned rider who lives for carving up mountain roads or someone who is frankly terrified of dropping a heavy two-wheeler in city traffic.
Which is a lot of people, to be fair.
Exactly. Or even if you're just a tech enthusiast curious about the bleeding edge of robotics, you are going to want to stick around for this. We're looking at a fundamental shift in how the daily commute actually functions.
Yeah, and the foundation of that shift really requires us to look at the internal hardware first.
Right, the Omo robot architecture.
Exactly. That's what Omoway calls their underlying platform.
Yeah.
Because the heart of the system keeping this bike upright isn't, standard automotive tech.
No, it's not.
It is a control moment gyroscope, or a CMG.
Yeah, I was looking at the schematics for this in the sources, and a CMG is serious aerospace hardware.
It really is.
I mean, this is the exact same stabilization technology they use to orient the International Space Station, right? To keep satellites pointed accurately at Earth without using thruster fuel.
Yep, that's the tech.
But applying that level of precision hardware to the incredibly chaotic, totally unpredictable environment of a city roadway seems like a massive leap to me.
It is a leap, but the mechanism itself is actually pretty straightforward.
Yeah.
It relies entirely on the conservation of angular momentum.
Okay, unpack that a bit.
Sure.
Yeah.
So inside the CMG, there's this heavy rotor spinning at a highly constant rapid speed. Now, the trick isn't just that it spins.
Right.
That rotor is mounted on a motorized gimbal.
Yeah.
So when the motorcycle begins to tilt, say gravity is pulling it down to the left because you stopped at a red light,
Yeah.
the system's sensors detect that micro shift in attitude, and the motorized gimbal instantly tilts the axis of that spinning rotor.
Okay, I want to make sure we visualize this clearly for everyone. If you've ever taken a bicycle wheel off its frame, held it by the axle pegs, and asked a friend to spin it really fast.
Oh, that's a great example.
Right, you suddenly feel this invisible, ghost-like resistance when you try to tilt the wheel left or right. It literally fights your hands.
Exactly, that's gyroscopic precession.
Yeah.
And that is the exact physical principle at work here, just, scaled up and motorized.
Wow.
By violently changing the axis of that spinning mass inside the motorcycle chassis, the CMG actively generates a powerful perpendicular countertorque,
So it's making its own force.
literally creating a physical force out of momentum that shoves the mass of the bike back to the right, restoring perfect equilibrium.
That's incredible.
Yeah, it's not passively resisting the fall with dead weight. It is actively fighting gravity in real time.
The sources highlighted a specific test that absolutely blew my mind regarding the system's reaction speed.
Oh, the seesaw challenge.
Yes. They put this riderless motorcycle on top of a massive mechanically moving seesaw structure,
Sounds like a carnival ride.
basically.
Yeah.
And as the platform violently tilted back and forth, the bike just autonomously balanced itself right on top of it.
Unbelievable.
No kickstand, no stabilizing training wheels, just the sensors reading the angle and the CMG firing off counterforce.
The processing speed required to achieve that is just staggering.
Yeah.
I mean, the system is reading the environment, calculating the required counter torque, and physically angling the gimbal in milliseconds.
Right.
Because any lag, and the bike just hits the floor.
But I have to push back on the physical reality of this for a second, because sure, software and math are great, But software doesn't eliminate physical mass.
Sure.
A CMG requires a heavy spinning metal rotor to generate that kind of force. So if I am a rider throwing this bike into a tight corner at 40 miles an hour, how do I not feel that extra 40 pounds of spinning metal dragging me down or fighting my countersteering?
That's the million-dollar question.
Right, because part of the joy of a motorcycle is how it leans and flows dynamically with your body weight. Wouldn't adding a satellite gyroscope make it feel incredibly rigid and clunky?
Well, that specific hardware limitation is exactly what killed previous self-balancing concept bikes in the past.
Oh, really?
Yeah, they felt like you were wrestling a mechanical bull that wanted to stay vertical while you wanted to lean.
That sounds awful.
It was. But Omoway bypassed this hardware limitation by fundamentally changing how the software interacts with the rider's inputs. The hardware is just the muscle. The software has to be the brain.
Okay, so how does the brain know the difference between me intentionally leaning into a curve and me, say, accidentally losing my footing on a patch of gravel?
Through the application of millions of reinforcement learning iterations.
Like AI training.
Exactly. Before they ever put a physical prototype on asphalt, Omoway's engineers built a hyper-realistic virtual physics engine. They placed a digital twin of the motorcycle into this cloud environment and subjected it to every conceivable variable: wind gusts, sudden weight shifts, tire slip, panic braking.
Basically, a digital torture chamber for the AI.
That's a good way to put it, yeah.
They let the digital bike crash millions of times, penalizing the algorithm for every failure until it learned the absolute perfect micro adjustments required to balance under any condition.
And it learned to predict rather than just react.
Ah, prediction.
Right. Because of that massive data set, the system synergizes with the hardware so deeply that the balance doesn't feel like a rigid add-on fighting the rider. It operates more like an instinctive core muscle group.
That makes a lot of sense.
Yeah, the telemetry data reads your deliberate steering input and temporarily detunes the CMG's resistance to let you lean into the turn naturally.
Oh, so it backs off when you want it to.
Exactly. And then it instantly snaps back to full stabilization the second it detects you coming to a stop or losing lateral grip.
That transition from hardware limitations to software intelligence is a perfect pivot point, I think. Because if this machine can instantly distinguish between human intent and environmental hazards, that gyroscope isn't just a fancy kickstand.
Not at all.
That mathematical precision is the foundation for an entirely new category of vehicle.
We really are looking at the dawn of what Omoway's founder, Todd He, refers to as the Moto 3.0 era.
Moto 3.0.
Yeah. He argues that the industry needs to stop thinking of these machines as motorcycles and start recognizing them as motor robots.
Red robots.
Exactly, which operates on the concept of embodied AI.
Embodied AI. I love that distinction. Because when most of us hear AI, we think of a chatbot on a screen generating text or, an algorithm curating our social media feed.
Right, something purely digital.
Yeah,
Yeah.
but embodied AI means the intelligence has a physical shell, limbs, an engine, gyroscopes, and a highly tuned sense of physical space. It interacts with the real physical world and experiences real-world consequences.
And the central nervous system for this embodied AI on the Omo X is called the Halo Pilot system.
Halo Pilot.
Right. It abandons the traditional setup where the throttle, brakes, and steering are all mechanically isolated components that the rider has to manage simultaneously.
Right, which takes a lot of skill.
Exactly. Halo Pilot takes the vision-based perception from the onboard cameras, the telemetry from the balance sensors, and unifies the motor, steering, and brakes into a single, cohesive response architecture.
And the feature list, enabled by this unified architecture, reads like a luxury car brochure, not a scooter manual.
It really does.
I mean, the sources detail adaptive cruise control, one-touch autonomous parking, and a remote summon feature where the bike literally navigates a parking lot to drive itself directly to you.
Which is incredibly cool.
It is. It even handles automatic reversing out of tight spots and continuous blind spot monitoring.
But the most disruptive element of the Halo Pilot system is the industry-first collision assist braking, or CAB.
CAB, right.
For a two-wheeled vehicle, this forces a complete reevaluation of motorcycle safety standards. Historically, motorcycle safety has been entirely passive.
Yeah, passive protection. Putting on a reinforced helmet, wearing an armored leather jacket, and just hoping that if things go wrong, the gear absorbs the impact.
Exactly.
You are entirely at the mercy of your own reaction time and the physics of the crash.
But Halo Pilot shifts the paradigm entirely to millisecond active safety.
Active safety.
Because the bike possesses that instinctive core muscle group and independent control over the brakes and balance, it can intervene faster than human neurology allows.
Oh, wow.
Yeah, so if you are riding and a car pulls out unexpectedly, the vision sensors detect the obstacle, the system calculates the braking force required, and the CMG braces the chassis to prevent the front wheel from washing out during the panic stop,
All on its own.
all in a fraction of a second.
Put yourself in this scenario for a second, because this is where the daily commute changes forever. Imagine you are sitting at a red light on a Tuesday morning. It is absolutely pouring rain. Truly. The road is slick with that dangerous mixture of water and motor oil. Normally, you're balancing a heavy, vibrating machine, shifting your weight, putting your boot down into a cold, oily puddle just to stay upright.
Sounds terrible.
But on the Omo X, you just sit there. Your feet are tucked safely on the floorboards, perfectly dry. The machine is holding itself perfectly vertical.
Amazing.
And then the light turns green, you twist the throttle, and the bike actively manages the rear wheel traction to ensure you don't spin out on the wet asphalt. That completely eliminates the low-level anxiety that acts as a massive barrier to entry for so many potential riders.
It totally democratizes the experience of two-wheeled travel. You no longer need years of physical muscle memory to ride safely in adverse conditions.
But, that brings up an engineering dilemma for me. If you have a machine constantly torquing a heavy internal gyroscope to fight gravity, the physical chassis has to be built to handle incredible shear forces.
Oh, absolutely.
It can't just be cheap plastic, or the bike would vibrate itself to pieces. So what does the physical body of this machine actually look and feel like to accommodate all this aerospace tech?
Well, the design language they chose is incredibly deliberate, and it completely abandons the friendly, retro styling common in the urban scooter market.
Yeah, it looks like a prop from a cyberpunk film.
It really does.
It actually won the 2026 EHEF Design Award. The chassis features these extremely aggressive angular lines, blocky bodywork, and a menacingly slim headlight array at the front.
Right.
It doesn't look approachable. It looks highly engineered and capable, and they built in some fascinating quality-of-life integrations to match that aesthetic.
Like the charging pad.
Yes, there is a wireless charging pad built directly beneath the chassis. You don't have to fumble with high-voltage cables in the rain. You just park the scooter over a compatible ground charger, and it juices up autonomously.
And, the aggressive styling masks a highly utilitarian core, too. The company categorizes the Omo X not just as a scooter, but as a smart, multiform electric motorcycle. Yeah. The entire frame is built around extreme modularity.
I saw the diagrams for this in the sources. It's essentially a transformer.
Basically.
Out of the box, it has the standard profile of a step-through city scooter. But the frame has integrated mounting points that allow riders to add structural body panels.
Right.
You can literally bolt on a faux tank area, transforming the seating position from a step-through scooter into a traditional motorcycle layout where you grip the center mass with your knees.
It also includes built-in subframes to attach hard-side panniers and a top box for luggage.
Oh, nice.
The engineering goal was to create a platform that serves as a nimble commuter from Monday to Friday, but can be physically reconfigured in your garage for a weekend touring trip.
That level of versatility makes a pricing strategy we found in the financial sources almost impossible to believe. The Omo X is projected to launch at around $3,800.
Which is just crazy. That figure completely undercuts the current market reality for luxury electric two-wheelers.
Totally. To put that in perspective for anyone looking to commute, if you walk into a dealership today to buy the BMW CE04,
The electric one?
yeah, which is a premium electric scooter with a futuristic design, you are bracing to spend upwards of $12,000.
Wow.
And despite that massive premium, the BMW still requires you to put your feet down at every stoplight.
Right.
Or look at the conceptual self-balancing bikes from a few years ago. Da Vinci Motors had a project in 2021 priced at $27,500, and it remained largely a niche concept.
Too expensive for most.
Way too expensive. But Omoway is offering aerospace stabilization, embodied AI, and modular bodywork for the price of a mid-tier gas-powered Vespa. How is the math working there?
It really traces back to the company's DNA. Omoway was founded by former executives from XPeng Motors.
Oh, okay.
Yeah, one of the major players in the electric vehicle space. They are building a supply chain from scratch here.
Makes sense.
They are leveraging mature, highly scaled supply networks from the electric car industry. Battery cells, vision sensors, computing chips, and they're just repurposing them for a two-wheeled footprint. The cost savings of tapping into an existing EV ecosystem are just immense.
Well, with that kind of aggressive pricing and cutting-edge tech, the standard playbook would be to launch this in Silicon Valley or maybe tech-centric European hubs like Amsterdam or Paris.
Normally, yes.
But they're completely ignoring the West for this initial rollout. They are deploying a hyper-localized launch strategy exclusively in Southeast Asia.
And choosing Indonesia as the global launch pad is a brilliant piece of strategic engineering.
Really? Why Indonesia?
Well, if the goal is to prove that your embodied AI and stabilization hardware are infallible, you don't test them on pristine, wide-open California highways.
Good point. You test them in Jakarta.
Exactly.
The traffic in Jakarta, known locally as Macet, is legendary for its complexity. You have millions of densely packed, low-speed scooters weaving inches apart, unpredictable pedestrian movements, and massive potholes.
A nightmare for AI.
Truly. Combine that with the torrential downpours of the rainy season, and you have arguably the most demanding, chaotic riding environment on Earth.
It is the ultimate stress test. If the Halo pilot system can autonomously navigate a flooded intersection in Jakarta during a monsoon without dropping the rider.
Then it can handle anywhere.
Exactly. It will effortlessly breeze through a commute in London or New York. The data they gather from the streets of Java will refine the AI exponentially faster than control testing in the West.
And the scale of this deployment proves they are highly confident in the tech. Pre-orders open in late April 2026, with the bikes hitting the streets of Jakarta in May.
Moving fast.
Very fast. They already have agreements in place with the dozens of local distributors to open over 100 retail locations across Java, including Bandung and Surabaya and extending into Bali. But the most interesting part of this strategy is the infrastructure commitment.
Yeah, they are totally avoiding the pitfall of just dropping an imported novelty into a developing market. The sources detail extensive plans for local production and assembly within Indonesia.
They are building a localized supply chain from the ground up.
Exactly.
They're creating local manufacturing jobs and implementing targeted training programs to actually empower local engineering talent in the smart e-motorcycle sector.
Which is great.
It is. They want this technology to integrate organically into an economy that relies entirely on two-wheelers for daily logistics and livelihood.
Which perfectly sets up the broader ambitions of the company, really. The motorcycle is just the Trojan horse for the underlying architecture.
Exactly. Buried in the press releases is a project called Mobility One.
Oh, right.
Yeah.
Okay.
Omoway is taking this exact same proprietary Omo robot platform, the heavy-duty CMG, the Halo Pilot AI, the vision arrays, and dropping it into a multi-purpose wheeled robot designed for commercial logistics and service applications.
That's fascinating.
It proves that the self-balancing tech isn't just a party trick for a cool-looking scooter. It is a highly adaptable, foundational robotic platform that can be scaled to move cargo just as easily as it moves commuters.
It underscores a definitive shift from humans operating dumb mechanical tools to humans collaborating with intelligent, embodied platforms that actively participate in the physics of movement.
Let's bring all these threads together. Omoway has effectively engineered a solution to the oldest, most fundamental pain point in the history of two-wheeled transportation: gravity.
Right.
By pulling control moment gyroscopes down from orbiting satellites and fusing them with the millisecond predictive power of embodied AI, they have built a machine that actively refuses to let you fall.
It's revolutionary.
They are taking the vulnerability out of motorcycling, making it accessible, fiercely safe, and completely stress-free for a generation of commuters who might have been too intimidated to ever throw a leg over a traditional bike.
The implications for urban mobility, traffic congestion, and rider safety are just profound.
They really are. And, our goal with these deep dives is always to take these massive, highly technical engineering shifts and narrate them in a way that is clear, engaging, and hopefully a little mind-blowing. But we couldn't do that without you. So, to you, the listener, thank you, sincerely. Thank you for lending your time, your ears, and your incredible curiosity to our show today. Sharing the sheer joy of this kind of technological discovery with you is the whole reason we do this.
It remains a true privilege to unpack these advancements together.
Before we sign off, I want to leave you with a philosophical thought to mull over. We started this deep dive by picturing that Omo X rolling out onto a stage in Jakarta, balancing itself, and parking without a human in sight.
Yeah.
If a motorcycle can actively balance its own weight, if it can navigate through dense traffic, apply its own brakes to prevent an accident, and then drop you off and park itself.
Where does it end?
Exactly.
Yeah.
At what point does it start being a vehicle you actively ride and start being an autonomous robotic companion that you just happen to be sitting on? And ultimately, does that level of perfect computer-controlled safety redefine the very soul of motorcycling? Think about it. We'll catch you on the next deep dive.